Hello, I'm Victoria McHale, and I'd like to take a few moments today to talk to you about welding safety. Specifically, I'm going to focus on two topics. The first is the required regular and routine leak testing of all hoses, regulators, torches, connections, all pressurized lines, and equipment for leak integrity. Secondly, I'm going to go over how to test a flashback arrestor and a check valve as required by many equipment manufacturers. Over the next few minutes, we will quickly go over some easy-to-follow steps to help everyone work towards a goal of achieving a higher level of workplace safety. This video is part of a series designed to help improve safety in the workplace. Please note the information contained in this video was obtained from sources believed to be reliable and is based on technical, regulatory, and experience currently available. It should not be assumed that every acceptable practice, test, or safety procedure or method, precaution, equipment, or device is shown, or that abnormal or unusual circumstances may not warrant or suggest further requirements or additional procedures. The equipment manufacturer's instructions, gas supplier's material safety data sheets, or MSDS, as well as important information listed on the cylinder label or bulk gas system should be read and followed. Any leak, even one quite small, can have a disastrous consequence. All connections, not just those using flammable gases and oxygen, should be leak tested only by an approved leak test solution before being put into use. A few examples should help us define why we have to use a leak test and what an approved leak test solution is. According to ANSI ASC Z49.1, Safety in Welding and Cutting, Section 10.5.2.1, leak testing connections states, leak test solutions for use on oxygen connections are commercially available and are recommended. Both U.S. and Canadian regulatory agencies enforce ANSI ASC standards, and employers may be subject to fines and additional liability if ANSI ASC standards are not followed. Further, the standard states connections shall be checked for tightness after assembly and before lighting torch. Flames shall not be used. In addition, when using pressure-reducing regulators, the CGA connections or union nuts on regulators shall be inspected before use. Most manufacturers in their product instructions require, after installation, a purge of systems and testing of all connections and equipment for leakage with an oxygen-compatible leak test solution at maximum working pressure for the appropriate gas shown on the product. All connections must be clean and free of damage, oil, grease, and other unapproved lubricants. The question that is often asked is, why can't someone just use soapy water? The answer to that is one of the dangers in working with an oxy-fuel process is the potential for oxygen and hydrocarbon, oil and grease, to combine and cause an oxygen-enriched fire. Although oxygen itself is non-flammable, it does support combustion of flammable materials. The concern here is the spontaneous combustion and fuel fire that may result from the presence of oil, grease, or combustible dust around cylinders, valves, fuse plugs, and safety devices. Oil and grease in the presence of oxygen may ignite spontaneously and burn violently. Next, I'd like to talk about specifications that define what materials can and cannot be approved in the leak detection system. The MIL PFR 255567E specification is designed to establish the basic criteria necessary to ensure that a leak detection compound used in oxygen is safe. The specification addresses this concern in two ways: by specifically prohibiting certain materials that can be used in the formulation of oxygen-compatible leak detectors, and by having these leak detection compounds pass 9 performance tests. The materials that cannot be contained in the leak detection solution are mineral oil, vegetable oil, animal oil and fats, any material that will ignite or explode when in contact with liquid or gaseous oxygen, materials that will act as primary skin irritants, skin sensitizers, or produce any other dermatitis, as well as ketones, aldehydes, and alcohols as components in the formulations. Now we would like to demonstrate how to test flashback arrestors and check valves for reverse flow. Many models of flashback arrestors contain check valves. Check valves are designed specifically to stop mixed gases from reverse flow into hoses, pipelines, equipment, and gas supplies, creating very dangerous conditions. Whether it is a torch model or a regulator model, flashback arrestor or check valve, they are tested under the same principle and it is easy to perform. First, my associate will demonstrate how to test the torch models. Please remember to always wear safety glasses and do not smoke. To begin, shut off the gases at the cylinder or line valve and safely vent the residual gases. Next, disconnect the torch from the hose and remove the flashback arrestor or check valve from the end of the torch. Then remove the hose from the outlet of the regulator and attach the torch model arrestor or check valve to the outlet of the regulator so that it is flowing in the opposite direction of which it was designed. Now submerge the outlet of the torch or arrestor or check valve into a glass of water. Once the equipment is set up, open the regulator and adjust the regulator pressure to approximately 3 to 5 pounds per square inch gauge or PSIG. Then conduct the test. Checking your results are very simple. If you have bubbles flowing from the flashback arrestor or check valve, then there is a leak and the unit should be replaced. If no bubbles are flowing or form in the water, then the unit passes the reverse flow test. The tests for the regulator model flashback arrestors and check valves are pretty similar. The startup is the same, so shut off the gases at the cylinder or line valve and safely vent the residual gases. To test the regulator models, first you must remove the unit from the regulator and reattach the hose to the outlet of the regulator. Next, attach the flashback arrestor or check valve unit you just removed from the regulator onto the end of the hose so that the flow arrow is going in the opposite direction. Now, submerge the outlet of the unit into a glass of water and open the regulator and adjust the regulator pressure to approximately 3 to 5 pounds per square inch gauge to test. The check of the results is the same. If you have bubbles flowing from the flashback arrestor or check valve, then there's a leak and the unit should be replaced. If no bubbles are flowing or form in the water, then the unit passes the reverse flow test. The next test applies to flashback arrestors only and should be performed if the gas flow to the application appears to be restricted, which is often indicated by shortened cutting, brazing, or welding nozzle or tip service life. Another indicator is poor gas flow and reduced quality and increased flashbacks. Then, the flashback arrestor should be replaced or flow tested by qualified personnel only. Testing equipment is available for gas and reverse flow testing. Contact your supplier for more information. Remember to always follow the manufacturer's instructions for use and maintenance and to consult them if you have any questions, concerns, or comments. Thank you very much for viewing this important safety message. For more information, please check out the following sources of information. And thanks again and be safe.